All right, welcome back, AP Environmental Science. We are still talking about global climate change. So, we talked a lot about human-caused climate change, but what about non-human caused climate change? Because when we looked at the data, there's an obvious relationship. There is obviously increases and decreases in temperatures, and it happens periodically, and it's a natural thing, and we shouldn't be so scared about it, except, well, let's talk about that for a second. So the path in the orbit and our position relative to the sun actually affects our temperatures and CO2 levels. The orbital tilt, the tilt in our orbit, affects our temperatures. And these change over, hundreds of thousands to millions of years. So let's have a null hypothesis. A null hypothesis is something where we're saying this is not true. So increase in solar radiation is what's causing global warming. And we're trying to prove this wrong, okay? That's what a null hypothesis means. We're proving it wrong. We're trying to say, here's my null hypothesis. I now want to prove this wrong. Because it's a lot easier to prove something wrong than it is to prove something true. So there's our null hypothesis. Keep it in your mind. Think about it. Now, if this were the case, wouldn't there be greater anomalies in the temperatures of summer, daylight, low latitudes? We'd see a lot more data changing if this were true. If solar radiation is what causes global warming, that would mean we'd have like really, really different temperatures just in the daytime versus nighttime, in the summer versus the winter. We'd see larger anomalies. So we can use these climate models to make predictions, okay? So this is a schematic for global atmospheric model, where they break things down into a horizontal grid, the latitude, longitude, and a vertical grid, which is the height or the pressure in the atmosphere. And we can measure things like air and ocean temperatures, the concentration of carbon dioxide and other greenhouse gases, and the amount of vegetation and sea ice. That's one of the great things about using these models of climate. So now let's get into some of the fun stuff, right? We're going to talk about a feedback loop. The feedback loop is very straightforward. Carbon dioxide, greenhouse gas, traps heat. Those warmer temperatures makes the warmer ocean, and therefore the ocean can't hold as much CO2, which means that the ocean is going to release more CO2 because warmer temperatures hold less CO2. So more CO2 is going to get into the atmosphere, which is going to trap more heat, which is going to cause the temperatures to rise more, which is going to release more CO2, which is going to trap more heat, which is going to warm the oceans more. This is called a positive feedback loop, where it just keeps going, keeps getting worse, keeps getting worse. There's a lot of positive feedback loops when it comes to global climate change, unfortunately. Another one, snow and ice has a very high albedo because it's reflective, right? It reflects energy away. It reflects light instead of absorbing it. As it melts, the dark land or water will now absorb more heat, which warms the temperature, which melts more snow and ice, which melt. You see where the feedback loop is here? Yeah, not good. Higher temperatures lead to more soil decomposition and by bacteria. That releases more CO2. More CO2 increases the temperature, which increases the temperatures to make more soil decomposition by bacteria, which releases more CO2. It's a really bad time. Tundra permafrost thaws and develops anoxic standing water, which causes anaerobic decomposition. So as the tundra permafrost is thawing, microbes in there start to have anaerobic decomposition, which releases methane. Methane gets into the atmosphere, traps more heat, melts more tundra. Positive feedback loop. Here's a negative feedback loop. Carbon dioxide stimulates plant growth. Plants then take CO2 in through photosynthesis. It does not cause more CO2 to be in the atmosphere, therefore it's negative. It stops, right? Positive feedback loop, it keeps going. It's a cycle. It gets worse and worse and worse and worse. It's a snowball effect. Negative feedback, more CO2, more plant growth, absorbs the CO2. Now there's less CO2, right? It's a negative feedback loop. Another example is more heat causes more evaporation. Water vapor is a greenhouse gas, but soon those clouds form, which actually shield and cool the area So that positive feedback actually becomes negative feedback. All right, so now we're getting into really 9.6, where we're talking about ocean warming. And I think this is where we're going to end the video. So the next video is going to be ocean warming, and then we'll do ocean acidification. Give you a short one.